How many people were there in the... Hi students. Hi, good evening students. Today's session is on center of mass and collisions. All right, very important topic in the entire mechanics. Yes, I know you must be wondering, every topic is important, isn't it? But let me tell you, this is one topic in which people generally spend a lot of effort in doing the question. They write down a lot of steps in solving the question, but ultimately there is no guarantee that the answer is going to be correct or not. Okay. By the way, what I am exactly trying to tell you out here is the steps are pretty lengthy. Generally, most of the questions, when you write down, you have so many equations, isn't it? You have the equations of conservation of momentum, energy conservation, and you have, like, so many other things that calculations become a little tedious. All right, now in today's session, students, I have handpicked some of the very interesting problems in this particular topic of center of mass and collisions, so that you would be able to solve the questions on this topic in a very fast way, in a very efficient manner. So you guys are ready to start off with today's session on center of mass and collisions. So students, let's get started out here. So everyone, just go ahead and click on the like button just before we start off with our today's session, and come alive on the chat as well. Hi Anna, hi Remake Songs, wow, that's a name. So let us go to our introduction. Well, let me introduce to you myself. Those who are watching this channel for the first time, my name is Sumit Kundu. I'm a BTech graduate from IIT Bombay, and I have a rank of 2125 in the year 2003. Students, it's been 10 years, 10 long years, a decade has finished that I have been teaching and training students, motivating them, coaching them about the entry to the prestigious college of this country. And it has been a pleasure interacting with so many brilliant students, motivating them, and kind of showing the path to glory and success. So students, what do we have here more for today's session? Let's just go ahead and see it. Well, this is a blessing. This is a blessing for all you students. That is at tinyurl.com/JEE mobile. Students, all the lectures that has happened in the last year is present like a video archive. So go ahead and watch. If you missed out on any of the sessions, if you're lagging behind in any of the sessions, you can just go ahead, go to this URL and watch all of these lectures for free. Okay, so, and coming back to this point here, students, let's just give you another good news to all the students who have just decided to subscribe for the Plus Unacademy Plus subscription. That is, use the code SMLIVE, and right away you should be getting 10% discount. Okay, so that's it, and now let's get started off with our questions. So here is my first question. Well, in the JEE mains, over the past few years, there has been at least one question that has been asked from calculation of the center of mass. So right away, they ask you to calculate the center of mass. Like in 2015, there was a question in which you had to find out the, it was a giveaway question. Okay, if you look at it, it was a giveaway question. Like, it was more of a theoretical question. They said there is a solid cone, and you need to find out the location of the center of mass from the top of the cone. Generally in the books it is given from the bottom, that is h/4. So from the top it will be 3h/4, right? Such a simple question, and you could have scored 4 marks. So that's the reason why we are so interested in this topic, that some of the questions from center of mass, all right, are really very easy, and they can easily fetch you that 4 marks. So for those 4 marks, let's take up 2 questions where we will be discussing about your center of mass. So let's get started out here. Okay, the first question. What is there in the first question? You have got a rod. There is a rod which is of length L. The entire length of this rod is equal to L. Okay, now what did they do? They bent it. They bent it in a V shape. Like, you know, I cannot bend it right now. It is going to break if I bend this. But they kind of bent it into a V shape. Okay, once they bent it into a V shape and they have made it like this, okay, that is, the angle has become equal to 60 degree. The angle of bend is equal to 60 degree. What you need to find out is the location of the center of mass. The location of the center of mass of this V-shaped rod right now with respect to this point A. With respect to this point A. So, how would we go ahead and solve this question? Okay, let's just look at the solution to this particular question. Students, are you all ready? Are you all ready to watch the solution right now? Give me a cheer, give me a yo, give me a like, and put a click on the share button so that it can spread out to a lot of places. Lot of live students should be participating in this particular channel. All right, chalo, let's have a look. Okay, see, now let's come back to our solution. This is a rod of length L. When you bent it, all right, how much will be the length of this part? L by 2. Very simple. What will be the length of this part from A to C? L by 2. Clear? Now, I know this looks like a kind of a symmetrical figure. This looks like a symmetrical figure. Okay, so let me just draw a line that is an angle bisector to this 60 degree. Clear? Now here the center of mass of this much portion of the rod, that is from A to B. From A to B, the center of mass will lie here somewhere at the center. Clear? And the center of mass of this rod will lie somewhere out here. So the total mass, let's say, is equal to your M. Clear? The total mass is equal to M. Let me see if they have given to us the mass. All right, they have not told us anything. There is a uniform wire of length L. That's all that has been given to me. Okay, so the mass of this portion will be M and the mass of this portion will be M by 2 and this portion also M by 2. Okay, now let me tell you some of the things very clearly. There are two methods to do this question. One is lengthy method, another one is a short method. Which one would you want to do? Definitely the shorter method. Okay. See, the lengthy method, I'll just tell you how do students approach this particular question. Okay. What they will do is they will find out the coordinates of the center of mass of this point. Say this will come out to be some x1, y1. Clear? They will also find out the coordinates of this particular point. They will say that the center of mass is here. So the point mass is, we can consider the entire mass to be a point mass located at this point. So they'll say this is x2, y2, and the location of the center of mass of the entire system, they'll use the formula x of Cm as m1, that is m by 2, x1 plus m2 into x2 divided by m1 plus m2. Okay. Now, when you do this method, it goes out to be pretty long. The solution stretches out to be pretty long. Okay, we are not going to do that because why? We are smart people, isn't it? You are going to be your future IITians. You are smart people. So, what are you going to do? You are going to apply a short understanding. Okay, that is, if I connect these two center of masses, the center of mass of the upper portion and the center of mass of the lower portion. Now try and understand, students, that any 2 point masses, by the way, option B is not the correct answer, Bharat. Okay, let's just have a look. Any 2 point masses, if you consider, the center of mass is going to lie on the line joining the 2 point masses. This is important point. Any 2 point masses, if you consider, the center of mass is always going to lie joining the two point masses. Simple enough. Now see this here. That means the center of mass is going to lie somewhere in between these two, right? On this particular line. Now here there is a certain amount of symmetry. There is a certain amount of symmetry. So I can directly say that the center of mass is going to lie somewhere out here. Okay, that means we need to find out this distance with respect to A to get what is the center of mass. Such a simple one. Now what is this distance from A to this point out here? If you look at it, this distance is half of L by 2. So this will be L by 4. This will be equal to how much? L by 4. So how much will be this distance? It will be L by 4 into cos. Now this angle will be equal to how much? It will be equal to 30 degree. Angle bisector ho gaya na? So this is 60. The entire is 60. So this will be equal to 30. So cos of 30 degree. So this will be equal to L. Just a second. This will be equal to L by 4 into root 3 divided by 2. So the answer will be root 3L divided by 8. Alright, easy one. Okay, so option C here is the correct answer. And what will be the y coordinate? Y coordinate will be equal to 0 because it is going to lie on this particular line. I can treat this as my x-axis. And A to be my origin. Fine enough. Did you all understand it? If you like this particular question, if you understood the solution, do not forget to press on the like, share and the subscribe button, students. Okay, chalo, let's try and understand another question. Okay, fine. So here in last year, I think 2018, a similar question had come in which there was a sphere. And a smaller sphere was taken out. Okay, and you had to find out the center of mass of the remaining portion, the coordinates of the center of mass of the remaining portion. So we have taken up something very similar. Now what is it exactly? See, I have got a circular disc. Which has got a radius of how much? It has got a radius of equal to 4r. It has a radius of equal to how much? 4r. Now from this circular disc, now I'm going to solve this question without even putting a ink on the board right now. Okay, now I'll tell you how we will do that, but some ink I'm going to put out here in order to explain to you the question. Okay, see, there is a circular region of R moved from this portion and a circular region of R moved from this portion out here. Okay, we need to find out the center of mass of the remaining portion. Clear? Now I'll try to do it by the traditional method first. That is the long cut method. And then as per this question, I'm going to do it by a shortcut method. Okay, so first we'll go ahead with the traditional method out here. Now, simple understanding. Now, students, sometimes some of the students have a difficulty in understanding the concept of something called as your negative mass. They have got a problem with that particular thing. Okay, so try and understand if I have got, like, you know, x divided by y. Okay, I've got a number x divided by y, all right, and if I add plus 5 and minus 5, will this ratio actually change? Definitely not, isn't it? Something very similar concept is out here. Okay, let me add some mass m naught and take away some mass. Let me add some mass m naught and take away some mass. That means the net mass that I have added to this is equal to 0. That means the figure will still remain the same. Similarly, I add here some mass m naught and take away some mass m naught. Still, the mass of this or the shape of whatever it looks like is going to remain the same. Okay, but when I add it, this entire portion gets filled up. This entire portion will get filled up. That means, what are you going to be left out with? You are going to be left out with one big disk, okay, plus one small disk, which will have a mass of how much? Minus m naught. And this entire thing will have a mass of m. Try and understand how we are approaching this problem, okay? Plus another mass of minus m naught. All right, so this system is going to have these three circular regions. One is full, which we got by adding this plus m naught and plus m naught, because here it was vacant. But when we added, we need to subtract it also. So I have got minus m naught and minus m naught out here. The idea is pretty clear to everyone. Okay, now let's go ahead to the next page and discuss about it in length. Now see, when we are doing it by the traditional method, what we are going to do out here? Let's see. See, this mass m naught, first we will try to calculate it. Okay. This entire mass, when it is like fully packed, this is packed, okay. Let's say that mass is equal to capital M. Okay. Simple idea. Now the mass is uniformly distributed over the surface area. What will be the ratio of the area of this smaller circle ratio to the bigger circle? Smaller circle to the bigger circle. Okay. So smaller circle will be pi r square. Bigger circle will be pi into 4r whole square. So I can write it as 1 divided by 16. That means my m naught will be capital M divided by 16. That means the small mass out here will be equals to capital M divided by 16. Simple idea. We got the masses. So far it is very, very clear to everyone. Okay. Come on, give me a cheer if you have understood this so far. Okay. And then we are going to proceed ahead. Okay, awesome, fine. Now let's see this once again. Okay, we got the masses of the smaller region, we got the masses of the larger region. Okay, now we'll go ahead and calculate the center of mass. It's very simple. Okay, so what is the location of this m naught, or let's say the negative mass that we have inserted out here? We have the entire mass, that is m. The m is located where? That is the entire bigger circle. We had three parts, right? Remember, the bigger portion, one smaller portion, and another smaller portion, right? So the bigger portion, the center of mass is located at 0, 0, right? The second portion, m naught out here, first we plugged it and then we took out something, right? So that is minus m by 16. Minus m by 16 will be located at which location? 0, 0, because x coordinate of it is equals to 0. So 0, how much? How much will be the value here? This will be 2r and this will be r. So this will be equal to 3r. All right. And then another one, minus m by 16, 0, or not 0, this will be equal to 3r. This will be equal to 3r, 0. All right. Now will we be able to find out? Okay. Definitely we can do it. We can find out x coordinate of the center of mass. We can find out the y coordinate of the center of mass using m1 x1 plus m2 x2, and we will get this as the answer. But I told you in the beginning. What did I tell you in the beginning? That we can solve this question even without doing all of these things. Okay. Now how do we approach it? Now there is someone who is asking it. Okay. So option C is definitely the correct answer. There is no doubt about it. But what I am trying to say is we can do this question. Even without putting a pen on the board. How exactly? Let's have a look at the figure. Okay. See students, let me take one entire circular region. Okay, let me take this entire circular region. Okay, we've taken it. Where will the center of mass of this circular region be like? Where will the center of mass of this circular region be like? At the center. At the center. Now, when I take away something from here, it's symmetric. But when I take away something from here, the center of mass is going to shift down. It is going to come somewhere out here. Okay. It is going to come somewhere out here. And then when you take out something from here, it is going to move somewhere out here. All right. Symmetric. Right. That means now the center of mass is going to lie in which quadrant? It is going to lie in which quadrant? First, second, and the third quadrant. Right? It is going to lie in which quadrant? On the third quadrant. In the third quadrant, x is negative, y is also negative. In my options, x and y both are negative. In which option? X and y both are negative only in option C. We didn't even have to solve the entire Mahabharat in order to get this question correct. Alright, so if you look at it, some of the JEE questions will have this kind of a shortcut, or let's say something to think about. They don't want you to be more mechanical, rather they want you to be more intelligent. Alright, so if you work it out in a smarter way, yes Mahir, I'll take a note of it. You can actually skip a lot of steps and save a lot of time in your valuable JEE mains examination. Alright, so here Yash Agnihotri says, sir, negative mass doesn't exist, then why should we follow just for the sake of answers? Well, negative mass does not exist. It's only a theoretical concept in order to get this question. Alright, in order to get a solution to this particular question. Alright, that means if you add a mass, this is like, same as the concept that I told you in the beginning. If I have a ratio x by y, if I add -5 plus 5 and then -5 to the numerator, will the ratio change? No, the ratio is not going to change, but it will help us in getting our answer. Similarly, the same concept is out here as well. You may call it not the negative mass concept, but rather we can call it as the superposition principle. When you say negative mass, it actually brings a negative connotation to the entire concept. Okay, so use the concept called as your superposition principle, wherein I am adding something and I am taking away something. That is a better way to look at the entire thing. Alright, by the way, if you didn't want to solve it by the negative mass concept, you can also do it by the shortcut method and get your answer. Alright, students, if you have liked this, do not forget to press on the like, share, subscribe. Okay, let's go ahead to the next question. Okay, now this next question had come for AIEEE 2004. This question was there in AIEEE 2004. Now this question also can be done by two methods, students. It can be done by two methods. Alright, see, number one method is the standard method. Standard method, that means where we are using physics. Number two method is what? Number two method is where we are using our smartness. Alright, so in the first method, what does the question say? That there is a block M. It is moving on a smooth surface. This block M is moving on a smooth surface. It will strike against this spring and will start compressing the spring. It will strike against this spring and it will start compressing the spring. They have asked us, let's say, the spring gets compressed by a maximum of length L. By a length L, then what will be the maximum momentum of the block after the collision? What will be the maximum momentum of the block after the collision? Now the concept is very, very simple. See, simple idea, just before it collides, let's say it has a velocity v. Okay, as it is moving on the smooth surface, definitely its velocity is not going to decrease. But let's say once it collides, what is going to happen? It is going to compress the spring. It is going to compress the spring. There will be a spring compression. There will be a restoring force generated. The spring force will act in this direction. Spring force will act in this direction. If the spring force is acting in this direction, then the simple thing is the velocity is going to decrease. The velocity is going to decrease, and it will go on decreasing till there is a maximum compression in the spring. So this is all the physics behind this particular question. Now they are asking us what will be the maximum momentum. The question is what will be the maximum momentum. All right. We can find out the maximum momentum corresponding to the value of maximum velocity. What is the maximum velocity? That is just out here. Now here, whatever is the total kinetic energy just before the collision will be equal to the net spring potential energy after the entire spring has got compressed. All right. So conserving the energy, you will get half m. Mass is m. So we'll take capital M, capital M. All right. Let's not take small m. Okay. Let's not take small m. Let me take capital M. Into V square will be equals to half k into L square. Half and half will get cancelled, which implies your velocity square will be KL square upon m, which implies your velocity will be root of k by m into L. And corresponding to it, the value of momentum will be m into this entire thing. So that will be k upon m into L. So this will be root of km into L. That is option A will be the correct answer. All right. Now let's say you did not know any physics. You had no idea how to solve this center of mass and collision problem. Okay. Can we do this question by common sense? Yes, we can do this question by common sense. Now, how do we do this question by common sense? Simple idea. Students, check for the dimensional analysis. Check for the dimensional analysis. You will get to understand that the first one will match the dimensions. Okay. Look at this. Simple thing. Okay. Maximum momentum. Momentum will have. Now see, I'll leave it to you. Check for the dimensions only. This one is going to, because I have got three very interesting problems. So we will be left out of time if we go ahead and do the dimensional analysis of all the options. Yes, dimensional analysis is one method which we can basically use when we have variables, like when we have physical quantities. Like you see here, we have mass and all. We cannot use it when we have numbers, right? We cannot use it when we have numbers, but we can use it definitely, because another thing, what really gives me an idea to use dimensional analysis in this question is that in option A, mass and spring constant and L, they are in a different format. Okay, here they are in a different format, here they are in a different format. That means all of them will never be matching the dimensions of the same physical quantity. They are all of these three. Out of these three, there will be only one which will be matching momentum, that is for sure. Okay, so you will get a clue and the hint by looking at the options itself. So students, I suggest when you are doing your questions for your JEE mains, after reading the question, okay, consider the options also once. All right, if you look at the different options, if those options, they somehow make some sense with the context of the question, use that and then go for the solution rather than jumping directly into the solution of the question and using long methods. See, long methods, no problem, you know the solution, good enough, but they don't want you to know just the solution, but they want you to know the solution in the minimum possible time. That is very important. Okay, now we'll go and talk more about it later, but now let's go on to the next question. Okay, now this is the same question. Now this is a very interesting question, and for this question also I'm going to teach you the long cut method and a single line solution. All right, and there is going to be just a single line solution for this question. I'm going to give you the long cut method also. In the long cut method, I'm going to talk about conservation of momentum, conservation of energy, and we are going to have so many different equations, and solving those equations will probably take you 10 minutes of time. But instead of using that method, okay, I'm going to teach you a shortcut method. I'll not say a shortcut, but yet yes, it's an optimized way. Rather than that, let's say it is an optimized way of doing it, right? So let us look at these two blocks, block A and block B. We have got block A and block B. Both are connected by a spring. Both are connected by a spring. Alright, so we are ready to start out here. Okay, fine, we are ready to start out here. We have already started, so let's go ahead. Block A is moving with a velocity of 12 meters per second, and block B is moving with a velocity of 10 meters per second. Got it? Block A with 12 meters, block B with 10 meters. Okay. The question is, they have given you the spring constant. Spring constant is 400 Newton per meter. This is got a mass of 6 kg. The other one is having a mass of 12 kg. 6 kg. 12 kg. Alright. Fine enough. Okay. Now, what will be the compression, the maximum compression in the spring? Fine enough. Did you understand the question? What will be the maximum compression in the spring? Now let us first understand the physics behind the question. See students, even if you have to apply the shortcut, you need to understand the physics. Okay. Some questions without the physics, like the last question, you just did dimensional analysis, but that is also physics anyways. But you need to know some amount, the logic behind the question. Okay. So they are asking us what will be the maximum compression. First of all, let us try and understand why there will be compression in the spring. Okay, there is this block of 6 kg. It is moving with a velocity of 12 meters per second. Now this velocity is greater than this velocity. Then what is going to happen? It will start compressing the spring. It will start. Listen to me very carefully. It will start compressing the spring. Now what is going to happen? This is having a lesser velocity, this is having a greater velocity, it is compressing, because of which now spring force is going to become active. Now spring force will act in this direction on block A and in this direction on block B. So what is going to happen to the velocity of A? Velocity of A will go on decreasing and velocity of B will go on increasing, and there will be a time when velocity of A and velocity of B will become the same. Alright, and when they become same, that time is the point when the spring will be having the maximum compression. Alright, did everybody understand? The point when the velocity of A will become equal to the velocity of B, that is the point when they will have the maximum compression in the spring. Now, traditional method to do this question, or the long cut method to do this question, what students generally do is that we will find out by the conservation of momentum, because these are all internal forces, spring force acting on block A, block B, these are all internal forces. So what is going to happen is 6 kg into 12 plus 12 kg into 10, this is the initial momentum, will be equal to the final momentum. Final momentum will be 6 plus 12, 18 into V, because I told you just now that maximum compression will be at the point when both the blocks will be moving with a common velocity. Let's say that is equal to V. Okay. Acha, now next thing, conservation of energy. Now conservation of energy we can do very simply, kinetic energy that we will do. So initially block was unstretched, was in its natural length. So no energy in the spring. Listen to me very carefully. I'm going to give you a one-line solution to this particular question. Okay, one-line solution. Now here what is going to happen? See, first conserving kinetic energy, half into 6 into 12 square plus half into 12 into 10 square clear, will be equal to half into 18 into v square plus half into kx square. All right. You will solve this equation, you will get the value of v. You put the value of v into this, you will get the value of x. That is the maximum compression in the spring. Okay. Now, students, we can do this question even without using those two equations. By the concept of something called as your reduced mass. Students, just put me a hi or whatever, a ping, if you know what is the concept of reduced mass. If you know the concept of reduced mass, come on, give me a hi or give me a cheer, all right, if you know the concept of your reduced mass. Fine. Dekho, I can't explain to you how do we get the derivation of the reduced mass concept and all that. See, the reduced mass is nothing but it is, some of you already know it. Good job, guys. Good job. See, if you consider everything from the reference point of the center of mass, okay, from the reference point of the center of mass, right, then we have a concept called as your reduced mass. Now, what is it? That is, initially these two together with respect to the center of mass, their net energy, that is kinetic energy of the let me just clear this. Kinetic energy of the entire system with respect to the center of mass is equal to half into the reduced mass into relative velocity whole square. Now, how did it come? We will talk about it in a different session. That is not the time right now, okay? Otherwise, this class will stretch to a very long class. But I want you to remember this method. All right. Kinetic energy of the system with respect to the center of mass, clear, is equals to half mu. Mu is what? The reduced mass into relative velocity of A with respect to B whole square. Clear? So initially what this system had was equal to the kinetic energy of the entire system. Now, after it got compressed, what was the energy? Energy was only spring potential energy, half kx square. Now you will tell me that, sir, you told us that A and B, they were combined and they were starting to move with a same velocity, right? So they should not have kinetic energy or what? Well, let us look at it. If you look at kinetic energy of the system with respect to center of mass, we consider relative velocity. And what did I tell you? That during maximum compression, A and B are both going to move with the same velocity. So if they are moving with the same velocity, their relative velocity will be equal to 0. Then kinetic energy of the system with respect to the center of mass will be equal to 0. That means initial kinetic energy of the system with respect to the center of mass will be equal to the spring potential energy during the time of maximum compression. All you need to do is equate this particular thing. Okay, you will get one line answer, that is 1 divided by 2 into mu. Mu is equal to, now this is equal to nothing but m1 m2 divided by m1 plus m2. That's it. Okay, now what is m1? This was 6 kg, this is 12 kg. So you will have 6 into 12 divided by 6 plus 12 will be 18 into relative velocity, 12 minus 10 will be equal to 2 whole square, will be half into k, value of k is 400 into x square. You solve it, you will get the answer. Half and half is going to cancel. 6 will go 3 times, 3 will go 4 times, all right. And what shall I have? 4 will now go 100 times. So x square will be equal to 2 square divided by 10 square, which implies the value of x will be 2 divided by 10. That means 0.2 meters. That will be the maximum compression in the spring, which we can get in one line solution. Students, did you understand the method? लगा के रेस्ट में कर देंगे. Well, no. That method is not going to work, my dear students. That method is not going to work. Okay, this is the most efficient method while you consider the reduced mass of the system. Most of the problems in your center of mass and collisions वाले में, ठीक है, जहाँ पे ना spring होती है and you have mass A and mass B, we consider the reduced mass concept to get the solution really very fast. Alright, chalo, now let's go ahead and look at the next question. Hope you liked and enjoyed this particular solution which we did only in one line, and if you have really liked it, students, do not forget to press on the like, subscribe and the share button. Okay, let's go ahead to the next question. What do we have here? One of the very standard questions of center of mass and collisions. Now, the most standard question is what? That there is a boy who is standing on a plank. There is a plank which is on the water. The boy is here. The boy walks up to this particular end. Then how much distance does the plank move towards the shore? Okay, something very similar, but we are going to do it by a different method. That is the most important thing here. Right, that we are learning alternative ways to look at the same problems that you must have learned so far. Okay, we had this block of mass small m. This small m is having a mass of 1 kg. Okay, it has a mass of how much? 1 kg. This bigger one is having a mass of 2 kg. The bigger one is having a mass of how much? 2 kg. This slides on this inclined plane. Clear? Now, as it slides, it comes down, and let's say in the future, it is somewhere out here. The question is, it's pretty big. Let me not take so big. Let me take it a little small. So somewhere out here. Okay. The question is, by how much distance will this block move? The traditional method or general method that students generally apply for this question is that they find out the center of mass initially. Then as it goes down, they know the coordinates of the center of mass. We also know, since these are all internal forces, the center of mass does not change its location. So we will say that this is moved by a distance x, then we'll calculate the coordinates of the center of mass. It becomes pretty huge. Okay, the number of steps involved will be at least 4 to 5 steps, and you will use a lot of valuable time in the examination. So this is what I really suggest, that you look at it from a different perspective, students. Now, if you look at it from a different perspective, what are you going to see? Let us try to see it. We'll use the concept of relative velocity and the concept of velocity of center of mass. Okay. Now, as this block kind of moves down to this particular bottom of this inclined plane. Okay. Now, relative velocity concept is, that is, we'll place a man on top of it. Okay. Now, with respect to the wedge, how much distance will he have traveled? Along the incline? Some distance. All right. Now, this distance, the distance will be along the y-axis and along the x-axis. Along the y-axis and along the x-axis. All right. Simple understanding? All right. Now, along the y-axis, I cannot do anything, because along the y-axis, there is gravity acting, right? So, I cannot do conservation of momentum. I cannot do anything else as well. Okay. I have to use kinematics and find out things, which is again going to be very, very lengthy. All right. Well, how do I do it in a very short time? Try and understand. Along the x direction, with respect to this observer, the distance moved will be equal to how much? The center of mass was initially located out here. This length is actually 3 meter. L1 is equal to 3 meter. So this will also be equal to 3 meter. Let's say the center of mass is somewhere out here, and right at the center. Let's say the center of mass is right out here at the center. Okay, so as it is moving along this direction and this direction, the horizontal displacement, try and understand what will be the horizontal displacement of this block. It will be equal to, see, the only thing which is required here is the visualization. It must have moved somewhere out here. This distance is 1.5, this distance is 1.5, so overall 3 gone. 12 is the total length from here to here. 12 is the total length from here to here. This side 3, this side 1.5, this side 1.5. So the horizontal displacement would be equal to 9 meters. Horizontal displacement of the center of mass with respect to this incline is equal to 9 meters. Right? So I can write down the displacement of the center of mass with respect to the wedge is equal to 9 meters. Now let's say this is moving with a horizontal velocity of v1 and this is moving with a horizontal velocity of v2. Clear? Now this velocity v1, okay, this velocity v1 and this velocity v2, if I consider, okay, if this is moving in this direction, then definitely the wedge will be moving in this particular direction with a velocity v2. Then what will be the velocity of one, that is this, with respect to the other? Can I write it as v1 minus v2? Yes, because I am considering this side as negative and this side as positive. Try and understand. This is v1 minus of minus v2. So this will be equal to v1 plus v2. Simple idea. What I am trying to do, I found out the displacement of this with respect to the block, the horizontal displacement. Let me write it here, x, the horizontal displacement. Clear? I found out the velocity, the x coordinate of the velocity of this block with respect to this. Find out. Fine. Now, how much will be the time taken in order to come from this point to this point here? How much will be the time taken to come from this point to this point here? The time taken will be 9 meters divided by v1 plus v2. Clearly agree? Now, simple understanding. Let's have a look at this. Okay. Momentum will be conserved. Momentum will be conserved in the entire process. Now, what is the momentum? Simple thing. You see, this has got a mass 1 kg into v1 will be equal to how much? 2 kg into v2. That means I can write down my v1 will be equals to 2v2. Conservation of momentum I have applied out here. Okay. Conservation of momentum applied. Put it out here. What do I get? I will get 9 times divided by 3v2 as the time taken. 9 times divided by 3v2 as the time taken. Is this clear? Then what will be the displacement of the bigger block? The bigger block along the x direction is moving with a velocity how much? v2. Is moving in this direction with a velocity how much? v2. v2, and how much time it has taken to come from here to here? The time taken is 9 divided by 3v2. So multiply it by 9 divided by 3v2, v2 will cancel, 3 will cancel it by 3 times. So the distance will be equal to 3 meters. Alright. Students, did you understand this particular question? Okay, very good, very good. Okay, chalo. Now let's move ahead to the next question, which I will give to you guys as a homework. So take up this question as a homework out here, wherein there is a body of mass 30 kg. It is shot with a velocity of 50 meters per second at an angle of 53 degrees with the horizontal. All right. At the highest point, what happens? At the highest point, it breaks into 3 parts. It breaks down into 3 parts. One part retraces back in the same way. The second one, it comes to rest, falls down. The third one will go with what velocity? All right. So what you need to do is conservation of momentum and you will get your answer. All right. So students, watch the last problem that I told you once again. If you understand that method, it is really a very, very short method to solve most of the questions in the in the center of mass and collision problems, all right, wherein you don't need to calculate the coordinates, rather you just need to use the concept of your relative velocity and the concept of the velocity of the center of mass. Okay, if you use that, you will be able to solve the questions in a much faster manner. Okay, chalo, now let's move ahead to something very important. Students, here, look at this. We need to interact, right? Send us as much messages as possible. Let us stay connected so that any trouble, any problem, any doubt, any query that you people have can reach out to us through the Telegram app. Okay, so what you need to do is download it and use the tinyurl.com/JEE live chat. Okay, and you can actually reach out to us. This is something I told you in the beginning of the lecture also. Using tinyurl.com/JEE mobile, it is an archive of the video lectures, the entire video lectures that we had of last year. So you can have an access to any topic, any chapter of the great educators that is there on this particular platform, all right, and you will have an access to that. Acha, most importantly, try and understand that if you have not taken the Unacademy subscription so far, what you need to do? Okay, you need to, first of all, let me tell you the benefits. Okay, see, you get to have the live classes, you get to interact with the educator, you have the live polls and the leaderboard, which make the sessions really very interesting. Okay, there are test series and analysis. Then you have got live doubt clearing sessions where you just need to click on the photograph and upload the doubts, all right. And most importantly, you have got so many educators with one single subscription. All right, students. So what you need to do is look for this Unacademy Learning app, install it. Once you have installed it, go to Plus, select IIT JEE, then use the code SMLIVE and right away get your 10% discount on joining the Plus channel. All right, now what you need to do, importantly, besides taking the subscription, do not forget to subscribe on this particular channel, students. Do not forget to subscribe. Why do I tell it every time? Because not just subscribe, but do not forget to press the bell icon. Because every time we have very important sessions coming up and we are strategizing, we're trying to bring in a lot of interesting things on this particular channel. So it becomes very important that you be notified of these important updates. So press on the bell icon and you will get lot of shortcut series, lot of other trending videos coming up for you students. So you do not miss out any of these episodes live. Okay. Next thing is you will get the PDF of all the things that are happening in the lecture. Okay, so what else can you actually ask for? And students, do not forget to click on the like, share, and yes, subscribe is already taken care of. By the way, JEE English is one of the channels. We also have these sister channels of NEET, JEE, Foundation. Visit them, tell your friends and spread the message as much as possible so that all of these things that we are doing for free can reach out to the maximum people in this country. And students, finally, the code SMLIVE, which will right away give you your 10% discount. Thank you, goodbye, and guys, keep enjoying, keep learning, have fun, and moreover, stay relaxed. Okay, as much as you try to be relaxed, the better will be your performance, not only in your boards but also for the JEE mains. Thank you and God bless you.